Hello, everyone, and welcome back to Mural Advisor, your guide to mastering research methods and statistics in the simplest way possible. Today, we're diving deep into a fundamental topic in research design, the sampling design process. If you've ever wondered how researchers select groups to study or why some samples represent entire populations while others fall short, this video is for you. What is sampling? Sampling is simply the process of selecting a smaller group, or sample, from a larger population in order to make conclusions about that population. But sampling isn't random guesswork. It follows a clear design process to ensure accuracy and validity. Defining the target population. The first step is to define the target population. We do this in 4 dimensions. 1. Element, the object of study, often the respondent. 2. Sampling unit, the actual unit available for selection, like a household, a school, or an individual. Third extent, the geographical boundaries. 4. Time, the time frame under study. Without these 4, we risk drawing conclusions from the wrong group. Basics of sampling and sampling distribution. Now, every response we collect is a measurement from a sampling unit. But here's the key. No 2 samples are identical. This is where the idea of a sampling distribution comes in. We rarely construct it in reality, but it tells us how sample averages would spread around the population average. The standard error measures this spread, and this is where the famous 68 to 95 to 99 rule applies. 68% of values fall within 1 standard unit, 95% within 2 units, and 99% within 3 units. This rule works both for raw data and sampling distributions. Sampling methods. Overview. Sampling methods fall into 2 big categories. 1. Probability sampling, where every unit has a known chance of selection. 2. Non-probability sampling, where selection is based on convenience or judgment, not pure chance. Probability sampling methods. Under probability sampling, we have simple random sampling. Every unit has an equal chance. Stratified sampling. Divide the population into subgroups, then sample from each. Systematic sampling. Pick every KTH unit after a random start. Cluster sampling. Divide into clusters, sample clusters, and study all units within them. Multi-stage sampling, combining methods to improve efficiency. Non-probability sampling methods. Non-probability sampling includes convenience sampling, selecting whoever is easiest to reach. Judgmental sampling. Researcher selects based on expertise. Quota sampling, ensuring certain characteristics match population proportions. Snowball sampling, starting with a few respondents who refer others. Expert sampling, selecting individuals with proven expertise. These methods are practical but less generalizable. Random selection versus random assignment. Here's an important distinction. Random selection ensures the sample represents the population, linked to external validity. Random assignment ensures groups within your sample are comparable, linked to internal validity. Determining sample size. When choosing sample size, consider importance of the decision, type of research, exploratory equals small, descriptive equals large, number of variables, analysis method, complex equals larger sample, resource constraints. In short, bigger and more complex studies require bigger samples. External validity and threats. External validity asks, can we generalize our results to other people, places, and times? The 3 threats are 1. Unusual people in the sample. 2. Unusual places where the study occurred. 3. Unusual timing of the study. Strengths and weaknesses of sampling techniques. To summarize, YASAT probability sampling. Stronger for generalization, but more complex and costly. Non-probability sampling, easier and cheaper, but risks bias and weak generalization. Wrap up. So, the sampling design process is about more than just picking a group of people. It's about defining the target population, choosing the right method, deciding on sample size, and ensuring validity for generalization. Done right, it forms the backbone of trustworthy research. If you found this breakdown helpful, make sure to like this video, subscribe to Merle Advisor, and turn on notifications so you don't miss our next deep dive into research methods. Remember, as I stated earlier, we are soon coming with a funds club where my fans will be accessing relevant material, including programming codes to build their statistical skills with R or Python, Stata, SPSS, SAS, and other statistical tool. We just need to reach 1,000 subscribers for the Fans Club features to be enabled by YouTube, so please subscribe and share with other like-minded group so that we can start this earliest possible. Thanks for watching. Drop a comment below. Which sampling method do you think is most commonly used in your field? I'd love to hear your thoughts.